Anybody ready for some 3D printing? Maybe, hopefully, here on a Sunday. Next one here is from Ryan. Hello, Lars. I watched some of your videos. I have a particular challenging problem. One of my designs have completely gone missing. Oof, that's bad. But I have an STL file of it, and I've used an STL to IGES converter. Okay. And though it said it failed twice to upload, I actually succeeded. Well, what do they know? The issue with the pieces is over 100,000 triangles. 100,000 triangles. Now, it's all faces, and I need to figure out how to turn it back into a normal solid without 100,000 triangles. All right, this is for all my 3D printer friends. And so I can make some adjustments that I need to make. I'm currently sitting in the patch asking to stitch it together as a file. Blah, 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 blah. So trying to get rid of these. All right, so what I thought we will do, because we have some fun here. What I did, let me just open up a new file. What I did was I actually went out and I felt like we needed a new STL file for our live streams here. So if I go out and say insert mesh, I brought down from Thingiverse, so I like Thingiverse, that STL file. All right, check this out. I'm going to show you a couple of different things with this. This was just way too fun, way too cool. Now, this is fine. This is an STL file, right? So if we don't need to make any changes to this, and I'm kind of like, Ryan, I'm moving a little bit away from your for your question just for a second. Of course, you could just have printed that. You could have opened up your 3D print application to send to your printer and be done. But if we wanted to convert this into a solid, we didn't have to. So what Brian did was he used an STL to IGES converter so you could get it converted. We don't have to do that unless holding that accuracy of 100,000 triangles is important. See, and I've talked about this before, but let me just quickly say it again. STL files is made up of triangles. You can see that here. Now, the more triangles you have in, the more accurate the shape is. So see down here on the bottom, this is not a very accurate shape. It's some big triangles. In here, we have some small triangles. And the smaller triangles, the more accurate the model is. The problem is that a software like a mechanical CAD software like Fusion has a limit on how many triangles it can use. So for Fusion, for example, we're looking at a span of under 50,000 triangles. And that's just how it is. Now, again, you maybe don't need to do anything with this model, but specifically for Ryan's, he wants to turn it into to a solid. So we're going to do that. So first thing I'm going to do, right click, and I'm going to say no capture design. That's going to get rid of the history tree. But what that let me do, folks, is we can select this STL, we can right click, and we can go and say mesh to B-wrap. So that means mesh to a solid. We can click here and say okay. Now we get a warning here that the facets on this model is 52,000. Conversion has been aborted. So you don't have to do this, Brian, because you already got yours converted. But what I'm going to do is I'm going to make sure that in my name up here, and under my preferences, I'm going to make sure in my preview that my mesh workspace is turned on. So I can go into the mesh tools, and then I can actually click reduce. And now I can just highlight this whole thing. And I can go to density, and I can bring the face count down. Now I'm going to, it could be easy to say, well, let's bring it down to 50,000s, but I'm actually going to bring mine further down just for the exercise here. 1, 2, 3. So let's bring it down to 20,000s and preserve boundaries. And let's just hit OK and see what we get. Now, this might take a little bit of time. But in this case here, let's click on the space here and see if the model is going to move. Oh, I actually did select everything, did I? Why is it still pre-selected blue? How many do we have now? Hide this whole thing, right click, convert to B-rep, new body. Okay, so now I only selected I don't know why I didn't select all of them. So now it says it can do it. Let me just go ahead and do that again. Understand why. That looks right. Reduce face count. Let's bring it down to 20,000. There we go. Now I brought it down to 20,000. So now you will see that this hand here is actually not accurate. Now, when I go now and try to turn it into a solid, highlight the whole thing, right click, and say mesh to B-rep. Okay. See, now it sees that it is at 20. It's not recommended, it's still a lot, but I'm just going to hit OK and try to do it anyways. So now we just got to wait a second as Fusion is kind of doing its magic here. There we go. Now the thing you want to do now, you see how it changed color. The thing you want to do now is you want to go over here and you want to make sure that this become a solid. See, this didn't become a solid. This became a surface. But it's very interesting, right? And I think that the reason this is if we go into the surface toolpath, we can try to highlight everything again. Just select the whole thing. Now this is going to take some compute power. If I go in here and say stitch, because we want this to become a solid. Hang on, let me think about it. There's 20,000 different triangles right now that Fusion is doing some calculations on. So this might just take a second. But what we will get out of this is that Fusion will actually show us that we have a gap in this model. That's why we ended up with that 20,000 surfaces, because it couldn't make it watertight. You'll see over here on the edge that it actually shows us some different areas, if you're looking at the model here, where there's some issues. So it looks like where are these gaps? So in here, see how it kind of highlights an area in there? So there's something going on right in that area in there where it hasn't healed it up. And this can really be, a pain in the neck. It's not Fusion's fault. It's because this solid model in the conversion process, it just couldn't make it watertight. Now, you can either try to repair all this, so go in and try to use some patch tools and things like that. But I'm not going to do that in this video. I just wanted to show you, if this happens to you, you know why. What I'm going to do instead, to get to John's problem, is that I am going to delete that surface body we just created. I'm just going to get rid of that. So just hit delete there, and I'm going to turn our mesh back on. I'm going to do something else just to have some fun. I'm going to go back into the mesh tool space, and I'm going to do a plane cut, and I'm going to select our mesh body. And then here for my plane selection, I'm going to select this plane here. And now I'm going to just remove all this. Like this. And I could choose to say fill. But I'm going to choose not fill, because that's going to kind of show you that problem we had before where it was just a bunch of surfaces. Oops, I didn't want it to cut off the hand or the finger. Let's go back in and do that again. My mistake. Cuts. Let's bring it back again. Let's bring it up in an angle a little bit. Like that's okay. I didn't want to get rid of the hand. Can I select this maybe? delete. Okay. So what I want to show you is actually what is happening on what happened before, just with those surface models. See, if I go in now and I say, all right, let's convert this over to a solid, and then I get to your thing here. Oh, we gotta be on the solid, right click. Okay. Now I just got the model a bit smaller, but this is gonna be easier. The reason that it couldn't become a solid before was because that there was a gap, right? There was a tiny little gap. Now there's a big gap. But this is my point. So what you could do is you could try to go in with the surfacing tool and try to repair all this. Now, I'm trying to do this a little fast. So I'm just going to select the patch. I'm just going to select that outer boundary. That's going to put a patch on it. And now if I go in and do what I tried to do before, highlight the whole thing, stitch it. And if you don't have any holes, if you don't have any gaps, what is the case now, what I just did, then when you hit, you see there's no gaps in here. Now when I hit OK, then you will see that it's going to turn this in. It's going to take these two surface bodies now. It's going to turn it into a body. That's really what we want. And that's where Ryan is. Now, I did all this work, Ryan, just to get to the point of showing you a couple of tricks to do this. So, first of all, know that if those 100,000 facets you have are like big facets, like on this flat plateau here, you can actually select that area, hit delete on your keyboard, and Fusion is going to try, whoops, you might have to go back in and turn your feature tree on. Fusion is going to try to heal this. Nope, it does turn it back into a solid, or to a surface body. Huh. That is interesting. There you go. So you can't be in this. I was under the surface tool about it. Then it just deletes it. You got to be under solid. So notice what's happening here. I'm selecting a face and I hit delete on my keyboard. Fusion is actually trying to heal up this face. It's actually removing these triangles. It's actually pretty crazy. Now this will take some time to do. I couldn't do that one. Let's try to go ahead here and select this face, hit delete. So you will actually see that I'm removing those top faces and making them more normal. And you could probably go, we could actually probably go around here, and if we did this long enough, we should be able to end up with a unified surface. So that is one way to do this. Now, another way to do, like the hand, you can't do this on, because on the hand here, this is it can't solve. I don't think it can solve that up. Like if I select this and hit delete, it will not keep it here. It just keeps it flat. That's why we can do it. But this is actually a curved surface. What you would have to do here would take a lot more work, Ryan. And this is just the nature, because you're coming from an STL file, we don't have better data. What you could do was you could go into the Sculpt environment. I'm just going to create kind of like a sheet here, like this, and I might just add some more segments in here like this. And if I go in here, right click, edit form, and just select all this. And this is definitely not a solution you're going to be super excited about maybe, but what we would have to do is we would have to rebuild all this up. Let me make it a little smaller. We'd have to build all this up as a sculpt. and I wouldn't even probably be up for this job. But what there is a function in here that will let you do under modify, will let you do a pull function. And that would actually pull these points to each closest intersection, right? And in this way here, you would actually be able to pull all these points. You could have window selected these points. But to get my point here, you could start like creating a sculpt over our STL file that is just triangles. This is a little bit like what I've said before when I'm using this terminology. Many times I say garbage in, garbage out. You know, like we don't have better data than this STL file, so therefore this is what you're gonna get, right? This of course will take some time to kind of like pull all these points to that solid model. So that is one thing you could do. Now, what I'm going to do to this model, just because, you know, if you watch this long here and you haven't turned me off yet, I feel like I owe you this. I'm going to delete. I'm going to finish this so you can kind of see how it will lay that sheet. And I made other videos about that. Now, what I would probably do between you and I, at this point, for anybody who watched this as a 3D printing, I would create an offset plane from the bottom here. Let's go in and look at it from side. I'm going to drag this up like this. And then I'm going to do a split body. I'm going to split this body, our hand body, with that plane I just created. Through there. And then I have two bodies. Body 1, body 2. I'm going to right click and remove body 2. I'm going to do a sketch on that bottom face there. I'm going to say C for circle. I'm going to draw circle out like that. Q for press pull. And I am going to give this something like that there. And that is now a solid body. We could start doing some engraving on it, but yeah. So that will be another thing we could do. Maybe you can replace some of the stuff with, cut some of the stuff away and replace it with new solids. And then it's maybe only certain areas like here where you have to do that. All right, I'm gonna finish this part here. I am gonna put a chamfer on this edge and this edge right there. Let's make it 5. Let's make it 2 like that. And go to Tools, go to Make, 3D Print. I'm going to select this model here. Now, does this one, friends, does this one need support material in here? This is always my question. Will this need support material? I don't know. Like somebody said to me, anything that is 45 degrees, less than 45 degrees. But I don't know about over on the side, inside of the hand here. Is that going to collapse? Maybe. Doesn't that also has to do with how many layers you do? I'm going to try to do this one. Somebody told me that 2 is better. And if we are doing no support material, will this hand fail? Somebody tell me out there. Somebody's going to leave me a comment. 5 hours to do this. Somebody, I should probably do a test cut. I'm just going to hit print. Anyways. And with that thing should stop running. Ryan, so yeah, not a perfect solution maybe to your 100,000s, but you really have, you can't just remove them like with a magic button because your STL file is the data you gave it that is just those 100,000 facets. So you really you got to kind of like remanipulate it. So either if it's flat, I would probably cut some stuff away, try to delete those faces if it's flat, or you're going to have to go into the Sculpt environment. I hope this was useful to someone. Maybe not. Thumbs up if you like it. Thumbs down if you don't. Comments, I love to get them, even if you think this was silly. And any advice you have, love to get that too with that 3D printing.